Alright, today we're going to start learning about something called stoichiometry. It's a really weird word, but it's also kind of fun to say, so say it a couple times, get used to it. Stoichiometry is switching, that's S-T-O-I-C-H-I-O-M-E-T-R-Y, and it's switching from one compound or molecule to another compound or molecule. So if I take my car out and I leave it in the rain, so my car is made of iron, and I leave it in the rain and it rusts, it becomes iron 3 oxide. Okay, that's rust. That, if we calculate how much rust we make from my car, we're doing stoichiometry. So switching from one thing to another thing, stoichiometry. To do this, we have to have a balanced chemical equation. So we've gone over this a couple of times, and let's look this up, and we're going to say that we have the iron of the car, and it's going to mix with the water that falls on it, and that is going to make iron oxide, or rust, and hydrogen gas. Okay, balancing this, we see that we have 2 irons on this side, only 1 here, so we're going to put a 2 there to balance that out. We have 1 oxygen here and 3 here, so we'll put a 3. Remember, you cannot put a 3 here. Okay, it's got to go to the whole compound, and that 3 is going to affect the H and the O. Okay, but now we do have 3 oxygens, so we're good, but now we have 6 hydrogens. So over here we're going to put a 3 here so that we have 6 hydrogens. Okay, and so this is now balanced. This is what we actually see happen. For every 2 atoms of iron in my car, I will make 1 molecule of rust, as long as I have 3 molecules of water to go with it. So now we're actually going to do the calculation to switch from iron into iron oxide. And to do this, we need to go back and remember, at the very start of the year, we were talking about these ratios, these conversion factors. Let's go over them again really quick. We have molar mass, which is grams per mole. We have Avogadro's number, which is moles per particle, or particles per mole, either way. And remember, particles would be your atoms, electrons, neutrons, protons, molecules, compounds, anything really small. The 2 that we haven't done a lot with, we've done a lot with these guys now. The 2 that we haven't done a lot with are molarity, and we're going to start doing a lot more with these guys. So molarity is moles per liter. And a brand new one that we're introducing right now is molar ratio. And it is moles of X, and X can be anything, to moles of Y, and Y can also be anything. Okay, it's just switching between 2 different things. Alright, so now using these things, let's go ahead and do this conversion really quick. We're going to say that we want to go from iron to iron oxide. Okay, and we're going to say that we start with 2,000 grams of iron. Now, a car has a lot more than 2,000 grams, I'm aware of this, but just to kind of keep it a little bit simple. So the way we're going to set this up, we're going to say 2,000 grams of iron. 1 more 0 there. Alright, so here we've got grams right here. If we look back at my conversion factors, the only thing that has grams in it is molar mass. So we're going to use that ratio, and I'm going to put grams of iron on the bottom and moles of iron on the top. Alright, this lets me cancel these ones out so that I can continue going. It gives me something new to work with. I've changed what I'm looking, how I'm looking at something. Iron has a molar mass of 55.85. And why I put it there, I'm not sure. That doesn't go there. It goes with the grams. Sorry. Okay. Iron has a molar mass of 55.85 grams, and that's to 1 mole. Alright, so now we're not looking at grams of iron anymore. We've switched it to moles of iron. Switching how we're looking at something. It's like my leg is 36 inches long or 3 feet long. It's just how I'm talking about it. We're switching that up. The next step is the new thing, the molar ratio. Alright, so the next thing we're doing, and sorry if I repeat it, I got interrupted a little bit here, but alright, so the next thing we're doing, we've gotten rid of our grams here, we're to our moles, and we want to switch from iron to iron oxide. So I'm going to put moles of iron down here, and the reason I'm putting moles of iron down here is so that I can cancel them out. So anytime you're confused about which one goes where, look at what you can cancel out. And I'm going to switch that to moles of iron oxide. Okay, so this is our new one, and this is what it does. Is it switches between, it's moles to moles, okay, moles to moles, and it switches between two different things. The numbers that we're going to put in, we are going to get from our balanced chemical equation. Iron oxide has a 1. If you don't write anything, it's a 1, and iron has a 2. So we'll come back over to this. 2 and 1. Alright, and that is from the balanced chemical equation. Alright, and then we wanted to know how many grams of iron oxide, so we're going to switch moles of iron oxide to grams of iron oxide. Okay, my moles will cancel, 1 mole. And we can hurry and figure out 55.85 times 2, because I've got 2 irons, and 16 times 3, because I've got 3 oxygens, gives me 159.7. I have 2 after the sig fig and none, or 2 after the decimal for sig figs and none after the decimal for sig figs. So we'll look at this guy, we'll round up. So this is 160. Come back here and go 160 grams. So you're doing sig figs throughout here too. We can look through. I've got 2,000 divided by 55.85 divided by 2 times 160, which means that if I left 2,000 grams, a 2,000 gram car, so maybe a big remote control car, out in the lawn, and it totally rusted, I would end up with 2,865 grams of rust. With sig figs, that's 4 in 2,000, 4 in 55.85, and 3 in 160. So with sig figs, we would say that it's 2,870 grams of iron oxide. And that is how you go from grams to moles, moles to moles, and moles to grams. And we will pick up with some molarity stuff in the next one.